So in this video, we'll be going over the disk method to find the volume of a curve. So now the formula is as follows. V volume is equal to the integration from a to b pi r squared, but r here is a function. And what I mean by a function is, let's imagine this now. So we have a normal cylinder. So let me draw it again. So as we can see here, the radius is going to be fixed for each point, right? So if we take the radius over here, it's fixed over here. Now what if we have the radius as changing each moment? So this could be a cylinder also, right? And here the radius is changing at each point. So that is why we write r of x, since in our curve, the radius would be changing at each point. And now we are going to rotate this curve either against the x-axis or the y-axis. So if it's against the x-axis, it's going to be dx, or if it's against the y-axis, then it's going to be dy. And here x is going to be between a and b. And another thing you might notice is this is the formula. Pi r squared is the formula for a circle, right? Area of a circle. So basically, volume is the integration of area. And that is how we are finding the volume over here. We are integrating area to get volume. So question 1 here, we are given a curve which is y is equal to radical x is bounded by x is equal to 0, x is equal to 4, and the x-axis, and this is rotated or revolved around or about the x-axis, and we need to find volume. So always the first step is to visualize the graph, and we need to graph this actually. So let's do that. So all I did over here is the curve here, which is this curve, is equal to radical x, and you can do that by simply putting any values for x and y here and substitute. So I put 0 and then 1 and then 4, and you get 0 here, 1 and 2, and these are the points. And this line, this vertical line over here, is x is equal to 4, so this is 4 and this is 0. And now we need to draw the reflection which we are rotating against the x-axis. So x-axis is going to act like a mirror, and you will have a reflection like this over here. Now this is what it looks like, and this is now a 3D shape. So this is what it looks like. And you have to imagine that this is a 3D shape. So it's not 2-dimension, it's 3-dimension, and there is like space inside this. And what now we need to do is we need to draw disk inside to visualize it and see what is the radius and find infinite number of disk inside. So let's do that. So here that is what it looks like, and now the radius of each of these disks, and I only drew 3 of these, but you will have infinite number of disks inside, and there will be so many that you have no space. And remember, this is a 3D shape, so you have very thin disk inside and you have infinite number of them. So what do you think the radius is going to be? It's going to be from this point to this point, right? Like this. And for this disk is going to be like this, and this is the outer last disk, so it looks like this. And whenever we are going up, it is always bounded by the line which is equal to radical x. So if you want to find the height, what is the height? If I draw it like this is going to the line. Oops, let me change it. And so is this, and so is this, and this line, this curve is equal to radical x. So what do you think the value of this radius is going to be? It's simply going to be y is equal to radical x, right? So simply here, if we use the formula, it's, oh yeah, the limits are from 0 to this line, which is line is equal to 4, right? So 0 to 4, and remember we are rotating against the x-axis. So this is the axis that we want to look for. So 0 to 4. And then I'm going to take pi outside since it's a constant. And r squared, r of x squared, is simply the function of radical x, right? So radical x squared, which is equal to x, since radical cancelled out with square. And again, we want to find the radius. Let me explain that again. Each of these disks, and every time we look at the radius, we are going to touch this curve, which is equal to radical x. So simply here, the radius is radical x, and we use a formula r squared. So radical cancels out, and this is against dx. So now just simplify and integrate. So now it's going to be pi from limit 0 to 4 x2 over 2, and the answer will be pi multiplied by, since the second time is going to be 0, multiplied by 16 over 2, which is 8 pi. And that is the final answer. So you can see why drawing the graph is so helpful, and you can immediately see what is the radius and use a formula. So for our second question, we have the equation of x squared plus y squared is equal to a squared, and right away you can see that we have three unknowns, right? So this is the equation of a circle. You should be aware of that, and it is revolved around the x-axis. So again, x-axis, so we need everything in terms of x here, so we need to rearrange this. Be y squared is equal to a squared minus x squared, and y is equal to radical a squared minus x squared, and we need to find the volume. So right away I graphed the circle, and to graph this you can also take random points, and here you have to take a since you have three unknowns. So it's going to be so x as a, so a squared, or actually let me just take this equation. So it will be a squared minus a squared, which is 0 as shown in here. So when we are choosing a as 0 here, it is 0, and negative a will be also 0, and so on. So you can graph it like that also, but you should know the equation of line for circle. And all these points are a, a, and a here. So now we are rotating against the x-axis, and we know our limits. This is minus a and a, right? So integration from minus a to a. And now let's draw some disk inside to see what the radius is going to be. Let me change the color. So each disk is going to start from the top and all the way down. This is one disk, and we have infinite number of more disks inside. This is the second disk, and I know it's not very accurate, but you can see what I'm trying to do. So now the main thing is, what is the radius of these disks? So each disk is, this is the radius in purple, and we are always going to touch that line, which is the line of equation, right, of the circle. So here simply again the radius r of x is going to be the line of equation for the circle. So here I'm going to write pi outside, and then r squared is going to be in terms of x here. So this equation, since we are rotating against the x-axis, so and that is radical a squared minus x squared, and then squared again. And here we can just cancel out that radical, since the square cancelled out the radical, and we're left with a squared minus x squared. Now just integrate this. So it's going to be pi limit from minus a to a, and remember we are integrating in terms of x, so we will treat this a squared as a constant. It's like 2 squared, and you have 4, so if you're integrating 4 is going to be 4x, right? So the same thing over here. So here is going to be a squared x, since a is a constant here, we are not integrating in terms of a, it's actually x, minus x3 over 3, and let's put in the limits now. So this is equal to pi into, we substitute x with a here, so it's going to be a squared minus a squared over 3 minus, and then open brackets. Oh, I forgot the pi. Okay, I need more space here. I'm gonna move it to the left here. This time we have to substitute with negative a, so it's gonna be a negative, actually a negative a cube plus a cube over 3. So now just simplify it. So it's going to be negative sign outside. Actually, I'm going to take the pi outside here as a common factor, not to confuse ourselves. And now let's distribute the negative sign. So it's going to be plus a cube. So we have 2a cube. And then this is going to be minus a cube over 3. So minus 2a cube over 3. Now let's make it the same denominator. So it's going to be times 3, since it's 1 over 1, right? So to make this 3, we will multiply the entire fraction. So it's going to be 3 here, and then 2 times 3 is 6. So the final answer is going to be 4a cube over 3, and don't forget the pi, and that is the final answer. So our next question is a bit more complicated, as we are rotating against y is equal to 1. So I need your full attention. So we know that the equational line is y is equal to radical x, and it is bounded by y is equal to 1 and x is equal to 4. So x is equal to 4 is a vertical line. Let me write it over here. X is equal to 4, and this line, this straight line, is y is equal to 1, right? And we are revolving around y is equal to 1 this time, not the x-axis. So the reflection is going to be from y is equal to 1 and here the 3D shape is going to look like this. So this is a 3D shape, by the way. And now if we focus on the radius, starting from the line which is equal to y is equal to 1, this, let me change the color actually. This is going to be the radius, right? This line from here to here, from here to here, and so on. So I just drew the graph larger, and it will be more easy to understand how we find the radius. So as I mentioned before, we know that the radius is this blue line, right? I'm gonna write it by lowercase r. And the other thing that we notice here is if we take the distance from here to here, it is going to be the line of equation as mentioned before, since it's always going to touch this curve which is radical x. And we know that this distance is radical x. And the last thing that you need to focus on is if line is equal to y is equal to 1, what do you think this distance is going to be? This is going to be 1, right? And so is this, and so on. So if I draw this simple graph, let me actually change my color, and I ask you, the entire distance is 5. Oops. And I tell you that this distance is, let's say, 1. What is this distance? It's going to be 5 minus 1, right? To find this question mark, it's going to be 4, right? So the same thing here, but instead of numbers, we have what is variables or functions. So we know the entire distance is radical x. So this entire distance is radical x. So that's what I'm going to write here, radical x. And we know that this fixed distance is 1. So what do you think the remainder is going to be? It's going to be radical x minus 1, right? For this part. And we know that it is continuously changing. That is why it is a variable. So simply, this distance from here to here is radical x minus 1. And that's it. So now we have our radius, and we can use our formula now. So I hope that is clear. If that is still you didn't understand that, I can explain it in a different way in the comment section. Please ask about it. So Now let's integrate. So now the limits is from this point. Wait, let me actually change the color again. So you can see it. This point to this point, right? And we know that this point is y is equal to 1. Now we need to find the x value for it. And if we substitute y is equal to 1 in this equation, we will get 1 is equal to radical x, and x therefore is going to be 1 also. So this point here is 1. So always when we are integrating against the x-axis, always the limits has to be in terms of x. Remember that? So here is going to be integration from 1 to this point here. You can see that. And this point here is x is equal to 4, right? This line. So this is 4 from pi. Now r squared was radical x minus 1, radical x minus 1 squared dx. Remember that also. And this is simple integration. You don't need to worry about that much. But the main thing here is finding the radius and then finding the limits and using the formula. So I'm going to simplify this. It's going to be integration from 1 to 4. And actually, let me actually simplify the square first. So it's going to be a squared, which is radical x squared, which is x, minus 2ab, which is going to be minus 2ab, plus b squared, which is 1. So now we got rid of that squared, and let's now integrate. So it is going to be equal to pi into limits from actually 1 to 4, x2 over 2 minus, this is 2, actually let me take 2 here, and then radical x is half, x to the power of half, so it's going to be x to the power of 3 over 2 over 3 over 2. So I'm going to times this by 2 again, and then plus x, since the integration of 1 is just x, right? And now we can take the limits from 4 to 1, and you will get the final answer as 7 over 6 pi. And don't forget that we do have a pi outside also. And that's it. So again, the integration is not the main focus of this topic. The main focus is how do we find the radius. As this radius, it was pretty simple actually. We just had to subtract two values, right? But the main thing is to graph it and then visualize how do we find it. And yeah, so our next question is a bit more different as we are rotating against the y-axis this time. So be very careful to read the question very carefully, and we are bounded by y is equal to y-axis, I mean to say, and the line is x is equal to 2 over y. So we have the equation in terms of x, so that's good. We don't need to do that ourselves. And we know that it's bounded by 1 and 4. So this line over here is actually y is equal to 1. Let me draw another line above it to say that's equal to 4. And this line is equal to y is equal to 4. So that is out of the way here. So 1 and 4. So right away we can write that the limits are from 1 to 4. And remember, we are rotating against the y-axis this time. So it's going to be a reflection against the y-axis. And the limits are from here, this part, to this part, right? So 1 to 4. And then pi, I'm going to take it outside. Now let me draw the reflection here. So the reflection is against the y-axis. So it's going to look something like this. Again, it's not that accurate, but you can visualize it. So now that's what it looks like. Actually, let me draw it in red color. So as we're rotating against the y-axis, this is what the reflection is going to look like. So now, what do you think the radius is going to be? If I draw a disk inside, the disk is going to look something like this. This is one of the disk. Okay, I'm not connecting it. It has to touch that line, of course. This is just one of the disk. This is a second disk, and so on, right? And again, I'm saying this again and again. It has to touch the line, and I know that my disk is not symmetrical or a very good graph also. But you can see here that the radius of each of the disk is from this line, which is the y-axis, to touching the curve, which is x is equal to 2 over y. So simply our radius is going to be 2 over y here, and 2 over y again as is changing, So let me actually write that over here. So just use the formula then. It's going to be r squared. So our radius is 2 over y, and let me change the color. 2 over y squared, don't forget that, and then dy this time. So yeah, let me show the radius again. So this is one of the disk, and the radius of this disk, imagine this is very symmetrical, is this to this line, right? And we are touching this line, which is equal to 2 over y. So simply the radius is 2 over y, and we just use the formula over here, which is pi r squared. R squared is 2 over y squared, and the limits are from 1 to 4 this time, since we are rotating against the y-axis. So now let's simplify that equation, the integration. It's going to be 4 over y squared. Now let's bring this above and integrate this. So it's going to be I'm going to take 4 outside, or you know what, leave it inside. 4 y negative 2. I just brought this above. Now let's integrate. So it's going to be plus 1. Negative 2 plus 1 is negative 1 over negative 1. Now the final thing we are going to be left with is minus 4 over y, and we have the limits from 4 to 1, and then pi outside, and the final answer that you should get is 3 pi. So our last question is a more challenging question, so I need your attention again. And we have the equation in terms of y, and we are rotating against the line which is equal to x is equal to 3. So we know that we are rotating against the y-axis. Now some basic equation that you should know is y is equal to x is a u graph, and then y is equal to negative x squared is opposite of that, so reflection. It's like an n, like this, and this was like this, and then x is equal to y squared is going to look like a c, so like this, the case that we have. And the last one is x is equal to negative y squared, which is the reflection of that, so it looks something like this. So these are the few graphs that you should know. Now let me just erase them. And we had the third case over here. And again, to graph this, you can also take random values for y, 0, and you get x is 1. So this is that point. This is 1, I think, yeah. And then other points, and you can get an estimate of the graph. And now to find the limits here are these 2 points. I'm gonna put them in purple actually. So this point to this point, and remember we are rotating against the y-axis, so we want to find the 2 limits that we are gonna have for the integration, right? And we know that this line is equal to x is equal to 3, and we are having an intersection with our own line. So what we can do here is we can equate these two, right? So x is equal to 3 and x is equal to y squared plus 1. So 3 is equal to y squared plus 1, and then it's going to be 2 is equal to y squared, and y is going to be equal to plus minus 2, right? Radical 2, I mean to say. So this lower point is minus radical 2, and this upper point is going to be plus minus radical 2. So we know our limits now. So that's one more step done. Now we need to find the radius, which is the most challenging part. So let me actually write pi radical 2 minus radical 2, and then positive radical 2. And if you want to see the reflection, is going to be a symmetrical circle, but we don't really care about that. Now if I want to see the radius of this graph or this shape, is going to be from the line x is equal to 3 all the way to the curve, right, which is y squared plus 1. So this is the radius in red, and so on and so on and so on, right, which is, let's denote this by lowercase r. So how do we find this smaller case r? So now I'm gonna visualize this on the side. So we know that the entire distance from here to here is going to be 3, right, since this line is equal to 3, right? And from the y-axis, this distance is going to be the line of equation, right? So this line, I mean this equation, this curve is equal to y squared plus 1, and that is given, right? And this is given in the question, that is equal to y squared plus 1. So this distance is y squared plus 1, and so is this, so is this, so is this. And we actually want to find this inner distance. So if I draw this right here, let's actually change the color. Let's say you're given the entire thing is equal to 3, and this part over here to here is given as 1. What do you think this part is going to be equal to? 2, right? Since it's just going to be 3 minus 1. So in our case, we are given the 3, and we are given not as 1 but as an equation, right? Y squared plus 1. So how do you think I'm going to find this unknown here, which is lowercase r? It's going to be 3 minus y squared, and this minus is going to be staying there. So if I distribute this now, it's going to be 3 minus y squared plus 1, like this. So now it's going to be 3 minus y squared minus 1, and I can change this into 2 minus y squared, and that's basically it. So once again, we wanted to find the inner radius of this shape, right? And let me just draw the reflection also, but that is not that important right now, so leave that. Actually, we want to find this, right? And we know that the entire distance is 3, as this line is equal to 3, the vertical line, and we know that the graph itself is y squared plus 1. So the distance from x-axis, or sorry, the y-axis to this curve will be y squared plus 1 and every point. So it's going to be 3 minus this to find the question mark. So that's exactly what we did over here. And this is also very easy to understand here. You know, you have the entire distance as 3. We know that this part, which keeps changing, it's not a constant, is equal to y squared plus 1, and we want to find the question mark, let's say lowercase r. So it will be just 3 minus y squared plus 1, and this is the radius. Now let's just plug in the formula. It will be 2 minus y squared squared dy. Don't forget that there is a square, by the way, on r of x, or sorry, r of y this time, since it's going to be in terms of y. Now I'm not going to go into too much detail, and I'm going to write the final answer, as integration is not the focus of this. It's the radius and of course the limits. So the final answer that you should get here is 18.96. So I do have a shortcut method for you guys, but only to recheck your answer. But you know, you still have to get your radius by graphing it and of course finding the radius. But you can just type this integration on your calculator to find the final answer, to recheck it basically. So I don't have a shortcut method for you guys for, of course, finding the radius, as you need to graph it to understand. And if you have any questions about any of the other questions we did in this video, you can always comment and ask them, and I'll be more than happy to answer. And thanks for watching.